So is this thing on? Does it actually work? Let's see. 1, 2, 3. Can I hear myself on YouTube? Yeah, it does work. Okay, cool. So, hello everyone. This is another surprise live stream, and this time I'm still trying to figure out like all my live stream setup, but most of it is now done. So now what I'm trying to do is I'm trying to somehow decorate this part of my background a little bit. And yeah, and this is what I want to do today. So let me just copy paste the link to the live stream a little bit here and there, as soon as I find a browser, I guess. No, that's actually a browser. Cool. Yeah, I actually should find, yeah, perfect. Here we go, yeah, and it works. Okay, cool. So let me pop out the chat. Hey, Mafus. How are you doing? Okay, cool. I think, oh no. Okay, cool. So what I'm basically doing today is trying to get this thing. Yeah, this is a laser cut logo basically from Plexi. As you can see, it's 3D. It's like opaque white on this side, and it's, well, it's kind of reflexive, but I'm going to get rid of this reflexive thing. You can see the lights up there. It's actually transparent, so you can maybe, can you see my hand? No, you cannot see my hand, but maybe you can see my hand now. I guess you cannot because, oh yeah, maybe here, look at the eye. You can barely see my hand. It's way more visible if there is a backlight to it. So that's basically what I'm trying to do with it. I'm trying to figure out how to get these LEDs on the back side of it. And oops, I need to get used to having that camera around there. So this is what I'm doing today. And I have absolutely no idea how to use these LEDs. So let's look at the LEDs themselves, actually. Okay, this is a microscope. Let's put it here and try to... Actually, let me move my chair here. I will get this in focus in a second. Okay. Okay, let's move it out a bit, I guess, more to the center. Yeah, how about now? And let's get this in focus. Yeah, so it's basically like this kind of an LED. And from what I understand, it's basically well, it's an RGB LED, and it, on top of that, it actually has like several, yeah, it has like several, it has a chip or something, because it's like controlled. Oh, Zanit, hey, how are you doing? This is like ASMR, but for eyes. Thank you for the donation. How are you doing? Long time no see. Hey, Charlie, Daniel, and Neolex as well. Okay, so that's the LED. And I need to figure out how it works, what protocol it uses, how to connect this stuff, is it addressable or not, and yeah. So I guess looking on the other side of the LED, if we kind of zoom it out, so let's do this, and let's flip it. Yeah, it has these four little, 4 pins, and I know that 2 of them are for power, 1 of them is for data in, and 1 of them is for data out. But for example, I have no idea, like the data out, is it like, do I need to terminate it, or do I just leave it floating? Like, also, is it addressable? So it's going to be basically reading the documentation today more than anything else. And yeah, I'm doing fine, Zanet, thank you. Okay, so let's switch to this, and I guess I'm going to need to look for the, to figure out what it is. This is a NeoPixel 5050 RGB from Adafruit. So yeah, it's exactly this thing, and I think they had a datasheet somewhere here. So yeah, like as you can see, maybe let's read through it. This is probably like some important information here, which I totally ignored while ordering it. So this is a 4-pin LED chip version. I guess I can switch. I can switch for now to this. Whoa, Blue Yeti, what are you doing? I can switch for now to this microphone, but okay, now it's a little bit better. Yeah, so it's a 4-pin version of, not the 6-pin version. Yes, I did notice. It's compatible, blah, blah, blah. Okay, I have no idea. These LEDs are chainable by connecting the output of one chip into the input of another. See the datasheet for diagrams and pinouts. I'm curious about that. To allow the entire chip to be integrated into a 6-pin package, well, it's a 4-pin package, but okay. There is a single data line with a very timing-specific protocol, which means, yeah, I guess like the frequency they mentioned here is kind of precise. Since the... Oh, by the way, just like a disclaimer, I have absolutely no idea what I'm doing. While I'm rather good with programming and reverse engineering and hacking in general, I am not great with physical stuff and electronics, so you have been warned. Feel free to correct me with everything. Kuba asks, so these are individually addressable LEDs. This is something I'm trying to find out, actually. I don't know. If they are addressable, that's great. If they are not addressable, I might need to figure out a workaround. I'm not sure yet if I need them to be addressable in all honesty or not, but yeah, like it's always cooler when I can have them addressable. Okay, since the protocol is very sensitive to timing, it requires a real-time microcontroller. That's okay, I have a whole bunch of them. It cannot be used with a Linux-based microcomputer. Yeah, I guess apart from ones which have an FPGA, I'm pretty sure you can get the timing right on an FPGA. Okay, the LEDs have basically a WS2811. I have no idea what is a WS8, what was it? 2811. What is this? It's a LED driver chip. Okay. Did they just link to the same thing? Yeah, but not, okay. They have a neon pixel library for Arduino, that's good. I have a couple of Arduinos. As it requires hand-tuned assembly, and it's only for AVR cores, okay. Yeah, that's normal. These raw LEDs are cut from a reel and or might be loose. They may not be suitable. Okay, I'm like going to hand solder it only. That's okay. And there's some video links and there's technical data. Weight 1 gram with something and a datasheet. Here we go. Rich says, the protocol for those is YAK. Okay, perfect, thank you. Yeah, if you joined late, then this is the LED I'm talking about, or maybe like let's get the intro again. I have this laser cut logo. It's pretty big actually. Yeah, it's laser cut. I'm going to sand it. I actually even have like a piece of sandpaper to sand it later on to be not reflexive but rather matte. And yeah, I want to stick LEDs on this side, where the opaque part is. Opaque, I guess I should say, opaque part is. And so on the back side of all opaque parts, I want to stick as many LEDs as I can. So they would be shining facing upwards. And then this is going to go, if we switch to this camera, yeah, it's basically going to go somewhere here. Maybe here, I don't know. I'm going to change the background a little bit anyway. But it's going to go here, and then the LEDs are going to be shining on the background is going to be reflexive, and therefore it's going to have like a nice glow to it. That's basically the idea. Yeah, so then I bought 160 or something LEDs from Ada, and they look like this, only if I actually can find her here. Yeah. Okay, this is how the LED looks like on the other side. Let me maybe fix the focus a little bit. And here we go. Well, I wouldn't call it a fixed focus, but okay. Anyway, so yeah, that's the LED, and it has like 4 pins on the back side, and that's what I'm trying to figure out today on the live stream, is basically how does it work? Can I drive it with an Arduino? Is it addressable? How do I need to connect the stuff? And maybe start designing a PCB, because at the end of the day, my idea is to basically design a PCB which is kinda, or rather a couple of PCBs which are kinda the shape of my logo, or rather half of my logo. That would be like 3 or 4 separate PCBs, I believe. And yeah, and then like solder the LEDs into the PCB. The PCB on PCBWay, I can actually get white ones. So yeah, that should give a pretty nice effect. Okay. Don't forget that you switched the microphone. Oops, sorry about that. I hope you heard a little bit at least. Okay, but I'm staying here, so I'm going to go. So yeah, so today is reading the documentation live stream. Maybe I will pull out the Arduino in a sec anyway. And again, disclaimer, I have no idea what I'm doing. So, this is an intelligent external LED light source with integrated, can I make it a little bit bigger? Integrated control circuit and light emitting circuit. Okay. Okay. Pixels contain intelligent digital interface that latch signal shaping and amplify drive electric wheel. Power supply voltage stabilization, that's cool. Built-in constant current circuit with high precision RC oscillator? Why do they need this? I don't know. I have no idea about analog electronics. Maybe that's important. The output driver adopts patented, I guess, like that's pulse width modulation technology, which effectively guarantees high color consistency. I don't need high color consistency, so the color is going to be off anyway, because, well, this is a camera, and the camera, as you've learned maybe from the last live stream I had, basically captures everything in grayscale. But it has like a set of a Bayer pattern of colorful glass in front of it. Well, it's not necessarily glass, it's some kind of transparent, partially transparent stuff basically, which makes each pixel have like 1/3 of the needed color information, but if you take that pixel and a couple of neighboring pixels, you can estimate what the color should be there. That being said, the thing is that that glass actually allows only certain wavelengths to pass through, right? And the LEDs also emit a certain wavelengths, and I'm pretty sure these wavelengths are going to be kind of incompatible, meaning that what I see as a human when I will look at the LEDs, at the color, will be totally different than what the camera sees, because that's normal. If you ever tried to take like photos of like with a cell phone of a sunset, then you know exactly what I'm talking about. You see one thing, but like you see beautiful colors of a sunset, then you look at the photo and you're like, oh, yeah. So I don't care about color consistency because it's going to suck anyway. All good. Okay, the data protocol is unipolar RZ communication mode. I have no idea what RZ stands for. But 24-bit data is transmitted from the controller to DIN, which is data in, on the first element, and if it's accepted, it is extracted pixel to pixel. What does it mean, pixel to pixel? Does it mean that it's actually like the first LED in a chain takes the first pixel, the second one takes the second pixel? Does it work like that? We'll see in a second. After an internal data latch, which means it captures that pixel data and applies it. The remaining data is passed through the internal amplification circuit and sent out the display output to the remaining pixels. This is amazing because this means already it's addressable, which is awesome. The pixel is reset after the end of data in. What does it mean reset in this case? Does it lose the color? Does it? But that's kind of weird. I don't understand it. I guess it will be clear later. Does it mean like it will stop shining after the end of color, which means like depending on how many pixels there are, it will shine only for that long? Which might be a thing, because that might mean like if you want to, you know, blink with it, then or rather fade it a little bit, then the normal way you do it is you just like tell the LED to turn on and off really quickly, so that for our human eyes, due to what was it called, like persistence of vision, we actually see it a little bit faded while it's just blinking rapidly. So maybe that's what we wanted to achieve here. Maybe I'm misunderstanding it. Using automatic shape forwarding technology makes the number of cascade pixels without signal transmission only limited by signal transmission speed. Does that mean that I can connect, like, I don't know, a lot of, I guess, these LEDs and it will work? The LEDs has a low driving voltage. Does it? Well, I guess comparing to what? Which allows for environment protection and energy saving, high brightness, scattering angle, good consistency, low power, yeah, everything. It's like totally the best LED ever. The control circuit integrated in the LED is integrated in the LED above. Cool. Main application, we don't care. Description, I'm not sure we care. Top SMD, internal integrated high quality external control line, serial, yeah, we know that. Control circuit, RGB, SMD 5050. This kind of means that is like half centimeter by half centimeter, like 50 millimeters by 50 millimeters. No, not, is that? Yeah, it is 50 millimeters. No, that's 5 centimeters. It's 50. What was below millimeter? I don't know. You know, like if you divide a centimeter, I guess, by 100, then this is what you have here. It's like half of a centimeter at the end of the day. To form a complete control of pixel, color mixing university, built-in data shaping circuit, a pixel signal is received after wave shaping and output waveform distortion will not guarantee a line. Data shaping circuit, I don't understand this. The built-in power on reset and reset circuit. The power does not work. What? The built-in power on reset. The built-in power on reset and reset circuit. The power does not work. This is weird translation, I believe. Gray level adjusting circuit. 256 levels of gray scale adjustable. Red drive special treatment color balance. That's cool. I guess if there wasn't it that the like red LEDs were a little bit dimmer than everything else, or was it the other way around? I don't remember. Maybe there's, yeah. Anyway, is it? Yeah, it's not a millimeter, right? Daniel is like whatever is after a millimeter. If it would be 10 to the power of -4, I guess that's what they use here. Red drive special treatment, yeah, line data transmission, plastic forward strengthening technology, no idea. Transmission distance between 2 points over 10 meters. Okay. That's a lot actually. Like for like 800 kilohertz, that's not going to be too troublesome to transmit that amount of data without too much noise. Especially like if every pixel, as they say, basically acts as a repeater, then it's not going to be bad. When the refresh rate of 30 frames per second. Wow, these are really pixels. They really thought about using these as pixels. Okay, when it's 500 hours. How much is that? I don't know how much is that. I want to know how much is that. Okay. Python, sorry, that's not 500 hours, that's 50,000 hours. Obviously, that's what, 24? That's 4 years? No, even more, right? That's 5 years. Yeah, that's fine. I'm okay with that. Especially that I wouldn't be using it all the time. Okay, yeah. So, how do I know which side is which? I mean, if we look at it from from this side, is there any indicator which is which? Like, what's the left side and what's the right side? Let me flip it. Alright, here we go. So, yeah. Looking at it this way, which one is which? I mean, am I looking on the top right? Sorry, for example, top right side, is it 3? Or is it 1? Is it like rotated by 180 degrees? How do I know that? Because that's the difference between like ground and VDD. I guess it will work one way and not the other, but the triangle, you say there's a triangle. Where's the triangle? There is no, like, if I look on the desktop, oh, this triangle. Wait, not desktop. Here, this triangle. Okay, perfect. So this triangle is pointing to, thank you, whoever said that, who did say that. Neolex, thank you. I did not notice, let me switch. I have not noticed the triangle, so thank you for that. Let's grab this maybe. Okay, where's the triangle? So the triangle is this here. Okay, cool. So if we have, wait. So if that's the triangle, then we know that that part is ground. Okay, cool, thank you, that's good. Daniel says that was like 10 to minus 4 is decimilli. Okay, decimilli, cool. Okay, so data and data. This is the recommended dimensions for PCB product. Let's take a look. How do they, because like soldering it will be, I don't know actually. Does it, if I look at it sideways, oh, okay, so that's good. If I look at it sideways, I actually do have, it should be actually pretty easy to solder. Yeah, it's like also visible on the desktop here. This is the metal part, I believe. Which is pretty cool because that's easy to solder. So this is what, 5 millimeters? No, I don't fully get it. Where is the metal part? Is this the metal part or is this the metal part? I'm confused. Well, whatever, doesn't matter. So they say to do 3.2 and this is to do 1.2 millimeters to 4 millimeters. Yeah, just doing, I guess, like 4 millimeters on each side. Yeah, that will be pretty easy to solder. Okay. So then the protocol, oh, this is power supply range to 5 volts. Cool, because I will have 5 volts probably. If I'm going for Arduino, I'm going to have 5 volts. Logic input voltage. By the way, I'm curious about like how does it actually do the data transmission? Does it like just like latch to the thing it needs and then it does it so fast that it doesn't really have any internal buffer for the, yeah, it probably has to be done like that. I was thinking like, does it like store some data which it needs to retransmit, or does it like just really quickly nab the data, large the data it wants for itself, and just continues retransmissions of everything else? And I think it's done that way. Okay, again, disclaimer, I have no idea about electronics and about physical objects, so please take everything what I say with a huge grain of salt. You'll need a multimeter. Oh, I'm not worried about a multimeter. I think I have all the equipment needed. Internal shift register. Yeah, Rich says internal shift register, and this is a pretty good... Yeah, I think that's going to be like that, because if they want to amplify the signal, an internal shift register sounds perfect. Will the Arduino have to power a lot of them as you plan? Yeah, I think so, but well, not Arduino itself, right? But rather whatever I hook up the Arduino to. I'm going to hook it up to the, like a universal power supply with enough juice to power it. Does it have like, how many milliamperes is it eating? We'll see. Is this like 12 milliamperes? Does it make sense? I don't know. I don't remember what are the amperes for LEDs. We'll figure it out. Okay, logic input voltage, VDD plus minus. Yeah, that's fine. Reverse voltage. Okay, working temperature minus 40. That's... Yeah, it's not. It's. I think I'm in this range with my room. I think so. ESD pressure. No idea. It doesn't matter. Why is it in volts? ESD pressure. Okay, I have no idea what this is. Like, literally, I have no idea. This is maybe... Like, ESD is electrostatic discharge, right? So does it mean, like, if a spark flies from my hand, will it survive up to 2K volts? Yeah, that makes sense. I think, like, usually a spark is around 1000 volts, so that would make sense. Okay, color. So yeah, we have... dominate wavelength, so I guess the wavelength is going to be, you know, like a typical bell curve, which is like kinda in this area. This is what I said, that like this might be, these wavelengths which are here might be a little bit incompatible with what the camera catches anyway, so I might need to do some adjusting. Like, for example, now the picture you see is kind of adjusted, so it's not what really the camera captures, but that's normal. Kuba says that each LED should take around 20 milliamps, so times 3, that's going to be 30 milliamps. But I think there's a difference with each color, right? Does this diode need any... Grzegorz asks, does this diode not need any resistor to reduce the current? I don't think it needs any resistor, but we will see. There should be a way, like a typical application circuit or whatever it's called. Okay, I see characteristics. I don't think we need anything here. Speed of transmission, typical 800 kilohertz, nothing min, nothing max. The duty ratio 67%. Okay. Really? Not 50-50? That's interesting. So the duty is basically like if you have a wavelength of like 0, 1, for example, then 1 is like how much of that sequence should be. I'm not explaining this properly. If you have like, okay, if you have a frequency and you take a single wave and you actually like change this to a 0 and 1, then the duty cycle would be like how long is the 1 versus the 0. So 50-50 would be their equal length, and 67 means like that a 1 would take more, I believe. Data 1 takes more of a cycle than a 0, but well, which might make sense because that allows for measuring the clock speed. Yeah, that's pretty smart actually. I like it. Transmission delay 100 nanoseconds. is that 100 nanoseconds? That's not bad. That's not bad. That kind of means that, like, if I have, what, 100 LEDs in one circuit, then the lag to the last one is going to be, like, totally ignoring the typical signal propagation of light speed, because that's probably going to be way faster. Than the lag at the end is going to be 10,000 nanoseconds, and that's 10 milliseconds, right? 10 microseconds, that's 10 microseconds. So yeah, 10 microseconds is nothing. Like, that's totally never noticeable by a human. That's fine. All good. The out conversion time, also nanoseconds, I don't care. Out RB conversion time, I have no idea what this, but this is like the same range, that's okay. Okay, so this is the protocol. Well, or rather, that's the electrical characteristics of the protocol. So if we have data in, then this is the lag between data in and data out, right? So this is the TPLH. TPAH. That's LH is, by the way, low to high and high to low. So if we go high, like this is low to high, right? Then this is going to be 100 milliseconds. And the same like is going to be here 100 milliseconds. Then a typical V out on RGB. What is V out on RGB? Sorry. Is this like after the signal is received, how fast will my RGBs light? Then it's pretty TR conversion. 200 milliseconds, that's, yeah, sorry, nanoseconds, that's nothing, that's perfect. Okay, then we have, yeah, so that's not the protocol, that's just like the characteristic, like low-level characteristics of the signal, which is fine. I don't think we'll have to implement it. Well, we don't have to implement it, because this is their, like, what they kind of guarantee by this LED. Okay, now what we have here, code period. We have T0, L, T0H, T1H, T1L, and TRST, which is a reset code, which is minimum what? Minimum units, here we go, that's microseconds. Okay, so if we want 0 code high level time, we transmit for 0.2 microsecond. The standard value is 0.3 microsecond. Oh yeah, so now I understand why they said that they need to be rather fast with assembly. Like, let's do some math. If we Python, we need Python, come on. Okay, so if we go with Arduino, a standard Arduino has, I think we can choose the clock on an Arduino from 8 megahertz to 20 megahertz, I believe. No, Uno clock. And not digital clock, like frequency, come on. Yeah, 16, but you can, I'm pretty sure you can tweak it a little bit higher, but they say 16. Okay, let's go with 16. So that means that one instruction on Arduino is going to, like, so one cycle on Arduino is 1 by 16, and that's seconds, but sorry, Python, could you print it in like a way I could read it? Yes, nice. Okay, here we go. So this is milliseconds, this is microseconds, this is nanoseconds. So 62 nanoseconds takes one instruction, which means that this amount is like 4 or 5 Arduino instructions. Like, we have only 4 or 5 Arduino instructions between when we turn this on, wait, and turn this off, which means, like, this isn't something like, oh, I do digital write and set it to like 1, and then I do a delay or sleep or whatever that's called, and then I do the digital write and set it to low, right? But because that already was like 5 or 10 microseconds, and here we have like 300 nanoseconds, right? So this is assembly code, which is like literally write to the port, do a knob, and write to the port again, probably, or something like that. So now I understand why they said, but yeah, for Arduino, we kind of need to like handwritten assembly code to drive this stuff. Yeah, LEDs, exactly. These kind of LEDs to be precise. Okay, but they have this implemented. This protocol uses a unipolar zero-ring code. Each symbol must have a low end. Each symbol in this protocol starts with a high level. The high time is determines the 0 or 1 code. That's interesting. When writing programs, the minimum symbol period is this. Because, okay, so I guess this is like high time and low time. And they say that typical is this value and the minimal is going to be this value. Fair. We could implement this, but whatever. If there's a library. You folks know I suffer from a not invented here syndrome. Sorry. So, okay, we've got table. Okay. Okay, so that's an interesting. I don't believe I ever saw a protocol like this. Not that I have a lot of experience with low-level protocols, okay, but that's nice because it's actually like just from the time you can take out. It's pretty resilient, whatever you say, however you say that word. Pretty resilient to noise, which is fine because they kind of operate on frequency here. And the reset code is rather long. Okay, so connection mode, we do this. As in like we do din-do, which I guess means like data in, data out, data in, data out. It's funny that they write like in fully, but out only first letter, but okay, consistency, I understand. So data refresh cycle, so we need to send a reset code. What's the reset code again? What is this? Oh, it's low. Okay, it's low. Okay, got it. So they sent first 24-bit, then second 24-bit, then third 24-bit. And then there's a reset code. And then they do, yeah, they resend like the diode 2 resends it. Okay, and resends the last. Cool. That's cool. That's really good, actually. The structure of 24 bits. I'm pretty actually surprised that for like an LED like this, they actually went for 24-bit code. Because like, I don't really think that they... Sorry, I made it a little bit like less quieter, like the microphone. I don't think that this LED can actually really do 24-bit code. Like a lot of LCD monitors don't even do 24-bit code. They do 6 bits per pixel, and then they use a trick which basically they flip between 2 colors with a certain frequency to emulate the 2 bottom bits of the 8-bit code, right? So I'm wondering if like can it really do 24-bit of color, or is it like just a typical protocol which is used in some high quality LEDs as well? Maybe it can. Maybe it can do like 8 bits per color. That would be amazing. Not that I need it, but it would be amazing. Okay, and we start with high. So we start from here. Yeah, that's reasonable. Kind of funny way they've written it. Like they could have like literally written it one under the other, but whatever. Typical application. Oh, there is a resistor. Somebody was asking about the resistor, but the resistor is on data in. Why is there a resistor on data in? Why do we need a resistor? 500 ohm resistor on data in. Okay. And then we need a resistor on data out. I don't understand this data out thing. is it supposed to be floating? Am I supposed to leave it floating here with a resistor? If I add a resistor, do I ground it? Okay, maybe it's written here. In the practical application scenario, the signal input and output pins of the IC signal input and output pins should be connected to the signal input and output terminals. In addition, in order to make the IC chip more stable, even the capacitance between beats is even the capacitance between beats is essential back. I don't know. I don't understand it. Application used for soft lamp. Yeah, okay. Suggested end of resistor. Why do I do a floating resistor? Can anyone on the chat, does anyone on the chat actually know why do I do a floating resistor at the end? Why is it grounded? I would understand if that would be like, I don't know, like 1 meg resistor grounded or something, but like 500 ohm resistor without, or maybe like even that grounded. Why is it not grounded? Well, they say grounding it. Maybe it's supposed to be grounded. Rich says like he never used a terminal resistor with these. Yeah, I would just ground this. And why do we have a resistor here? Either like 500? Are they actually doing? Is it the pull-up circuit? I don't know what they do internally. Doesn't matter. Whatever. Okay, LED performance, red. So yeah, red is a little bit, I guess, darker than the other ones. Wavelengths, yeah, as I said, bell curves, that's kind of what's expected. I'm really curious if I could find on the internet the wavelengths for the cameras I'm using. A typical radial pattern, I have absolutely no idea what this means. Standard packaging, okay. And some other stuff. Okay, cool. So I kind of know what I'm dealing with now. This looks pretty awesome, actually. I like it. So I think what I should do now is I should get like 3 of these and try to connect them to an Arduino. And okay, so I can, I guess, put the logo away for now because it's, if you're just back on the, like, just joined the stream, the idea is to hook up LEDs on the back side of it, not on the front side of these, but like on the back side, pointing this way, so then I can like attach it to the background of my live stream. Okay, so let's put this away. Now I will need an Arduino sooner or later. I have 4 of them. That's good. Let's use this one, for example. I could probably use a breadboard sooner or later, I guess. Probably not a big one. And I don't know, maybe a couple of cables. Yeah. Okay, now what else do I need? Okay, so I need to figure out how do I solder this stuff? I mean, I could just I guess just grab a breakout board and solder this thing on a breakout board, right? So I like grab it from this side. Oops. Here we go. Yeah. Yeah, and I like just put it on a, oops, where are you going? So I just put it on the breakout board, which is compatible, and solder it. And I might have a proper breakout board, so let's Yeah, as you can see, I'm still running between my desk basically to switch the scene. But later on, I will actually have a tablet or something on my main desk to be able to switch scenes, so I won't have to run away. Where are my breakout boards? Pin headers. Oh, breakout boards. Here we go. Okay, so I guess like the question would be like which breakout board actually works with this kind of diodes. Nie stwierdzono, by the way, this isn't a LED strip. These are like individual LEDs. Secrus, I will be using the library, unless it doesn't work, then I won't be using it. Okay, please give me that LED. Here we go. There might be some delay between one and the other camera. I apologize for that. Is this? Nope, that's the wrong one. Can you actually see something? I hope you can see something. Maybe I have quite a lot of breakout boards, as you can see. Maybe this one? Yeah. I think this one works. Okay, it will work. How am I lucky enough to even have like this thing for it? And how many of these like pins for it already soldered, and I don't have to solder them? That's good. This one is identical, and one more like that maybe. I guess I can test it with 2, but 3 would be a little bit better. Okay, let's go with 2. I don't see another one. Oops. So I also need another LED, I guess. Wondering, yeah, this is I guess the center. Maybe I should like actually like draw something on this so I know where's the center of the camera feed. Yeah, so I have like 160 of these. Like this is just like obviously 10, but I have way more than that. Cool. So now what I'm thinking of doing is just like putting this here and soldering it while it's already inside, but this might melt a little. So yeah, maybe I shouldn't do that. But it does make soldering way easier, so I am going to do that. Okay, let's switch to the other side of the desk for soldering. I don't have to solder this under a microscope, but I am going to solder it under the microscope anyway, just because I have a camera set up here. So let's do it like this and like this. Here we go, and I'm switching to the microscope. Okay. Here we go. No. Okay, I'm going to turn on the, well, I'll turn it on a little bit later, but it will be a little bit noisy. So let's get, I'm wondering if I can actually show the other camera here. Give me 1 second. So let's grab this camera. This is the front BMD3. This is this one, yeah. Copy, microscope, paste, and put it here. This is, wait. Okay, now let's do. Alright, perfect. You can barely see me there, but I will be there trying to solder something. Okay, this looks good. This looks good. So 300 degrees, I guess. Since I'll be soldering under a microscope, I guess I don't need safety glasses. Do I need to clean this? I just use flux, I guess. You know what? I can actually move the camera a little bit. That's why actually got it like this is a movable camera. So let's move it a little bit. Okay. Here we go. It's a little bit dark. Let me fix that. Okay. Let's move it a little bit. Yeah, okay. I think you can deal with that. Okay, this is kind of ready. My solder, here it is. Now I don't fully really care about where is going to go, like which pin, I guess. Yeah. I'm going to do the same with the other one. But let's try to yeah, that's been good. Yeah. I think that's fine. Yeah. Okay, how sharp is it for you folks? Sharp enough. Let's put it in a way so it doesn't, like, nothing falls. I'm not sure what actually did anything. Yeah, that one better. Okay. I think it actually worked. This is weird. Okay, it can be bridged. I don't care. Okay. So that's one. Let's do the other one now. Okay. So which... oh, I did it the other way. Yeah. know what, I actually should fix the one on the top of here. Yeah, now I'm happy. Yeah. Yeah, I think. So before I put it away, let me actually verify it under the microscope if it's actually fine. I'm not turning my iron off yet. So let's see here. Yeah, this looks fine. Let's see then here. So that's fine. Then, wait, here, can I see it here as well? This is as far as my scope goes, okay. So let's look at this one instead. Yeah, this one looks good. I have a bridge there, but I don't care, in honesty. I'm going to reverse both of them. This one looks good. Yeah, I don't think NASA would hire me, but yeah, it will do. So now I can put the soldering iron away. Okay, and we can switch to the other camera. There we go. Now I need to check the chat if everyone is laughing at my soldering. And let's see, I didn't solder for a long time. Solder some legs. I don't think I need to solder the legs. I should probably clean it though. At least a little bit. I honestly don't like stuff like this being, like still having the residue of the flax. So, okay, I can put it this way. This is somewhat clean. This is somewhat clean as well. Should probably switch the camera to point at something meaningful. Let's move it here. Okay. Okay, and now it's a little bit too bright. So exposure 70, there we go. Let's clean it, I guess, a little bit at least. this is isopropyl alcohol. What can you see? Yeah, let's get maybe with this. Yeah, I didn't use that much flux, so I don't think I have to do a lot of cleaning here. There we go. Okay, there we go. I'm going to actually open the window since isopropyl alcohol smells a little bit. Cool. So, what do we do now? Now we connect it to an Arduino. Give me a little bit more of that stuff. Okay, so we have an Arduino, we have a breadboard, we have two LEDs which are almost dry. Let's speed up the drying process a little bit. This is the most important tool ever. You can dedust stuff with it, you can like make sure stuff evaporates a little bit faster. Okay, so let's put this one. What's actually connected where? This is connected to here. I don't know what is where. Just a multimeter. Okay, so I should usually go like this. Okay, so this is obvious. This like here is connected here. This is obvious. Where is the other one connected though? This one. Like where is this one connected? Oh, it's here. Okay. So I'm guessing this one will be here, and this, oops, and this one is here. Okay, cool. That's not bad. Obviously I'm going to forget it in a second. Which means we can do this one the same way. Where's the triangle? The triangle is here, the triangle will be here. Okay. Cool. Now give me that data sheet again. Okay, desktop. Product overview, where's the pinout? Oh, here we go, there's a pinout. Yeah, I expected something more complex, but I guess, yeah, why would I get something more complex? So, triangle ground. Okay, triangle ground. So let's grab some, I guess, black wire for it. Triangle goes here, and here is here, so I guess this is ground. Let's make ground here. Okay, then on the Oops, I guess you don't see me. Okay, so that's the ground. Now VDD is on the opposite side. That would be the power. The opposite side being here, so that's 4. So let's grab, I guess, red. It's too long. Do I have a shorter red? No, I need this one. Yeah, one thing I learned is you never have enough of these cables. So this one goes to, oops, that's the wrong one. Yeah, let's just use a too long one, whatever. This one goes here, and this one goes here. They just go to the ground, right? Like in the typical application. And let me quickly scroll through it. Okay, so typical application shows that, yeah, there is no kind of resistor between VDD, which is like 5 volts. Okay, that's fine. Now we need to connect data in to Arduino somewhere. We should also connect the ground to Arduino, but whatever, that comes in a sec. Yeah, green one sounds good. Which one do we use? We use digital. Oh, do we have to use actually like some specific one in the library? I don't know. I'm going to leave it for later. Where's my data in that case? Data in is on the same side as ground is, so on this side, which means it's going to be this one. So this one is data in, and I'm going to go with this to the Arduino, and then I need to connect the data out, which I guess is here on the opposite side. Yeah, and I need to connect it to data in on the other one. Yeah, totally no noise in the circuit, totally no noise, but that's okay. And then we are going to go with, yeah, I guess this one. With the data out from here into a resistor, they said 500 ohms, right? Let's go with it to the ground, so let's go maybe here. Yeah, and they said 500 ohms were my resistors. My resistors are somewhere here. Okay. And they said 500 ohms. So I have 500 ohms here, 470, oh that's kilo ohms. Do I have like 470 here, this one? Is it this one? Yes, this one, and I need 2, I believe. Let's just check. No, I do not know the colors of resistors, I'm sorry. So, let's see it. This one is... Oh, I'm touching my hands, I guess. 500 ohms, perfect. Does this work? Oh, this one has low battery as well. Well, if both colors are the same and it showed 500 ohms, I'm going to go with 500 ohms, and I guess I need to replace the battery in this one, really. Let me try that for a sec. Yeah, that's better. Okay. Sorry, it did show like 400 ohms, 470-ish. I do need to change the battery in both, actually. I don't remember what was the last time I did change the battery here. Okay, so let's go with 500 ohms. Why is it 500 ohms only to ground from this? I'm not sure about the 500 ohms from this, but this is what they said, right? So let's do this to the ground. Okay, and this here. But I hope they have like some maybe that's okay. If it gets hot, then I'll replace it, but maybe it's fine. And then they said, oh, they said actually I need to get this one through data in as well through a resistor. Let's get it here then. Okay, and now I need to connect to Arduino. So this one will go to Arduino. Now, I don't know which port to put it in. I'm going to check the chat if somebody says that, hey, I don't touch one side, yeah. Okay. DI goes to PWM pin, that makes sense. ABC says that 500 is big, but for a terminator resistor, okay, maybe. I do not have experience, honestly, with how like large should the terminating resistor be. But if they say 500, then yeah, like what could go wrong, right? I'm pretty sure like there are resistors on the Arduino side anyway. Perfect. So NeoPixel library. Library. Here we go. Okay, blah blah blah. How do you connect? Oh, I don't think I have Arduino Studio installed. I don't. I have to install it. Wow, that's a new. Okay, now pixels begin. Let's start with Arduino. Okay, Windows, Linux, app image. Oh, I can get app image. No, I don't want app image. I want this one. Just a note. Okay. Now I do need to extract it somewhere. Where do I extract it? I guess, do I have a bin directory? No. Okay, I get it. Yeah, sorry, I know you're not seeing what I'm doing. Okay. Okay, here we go. Wow, that's a lot of warnings. But hey, it works. Select board. I'm not selecting a board because I don't have a connected board. Oh, that's going to be painful. That's one thing I didn't think about. I need to somehow connect the board to a computer. Yeah, let's let it install. How did they say to install the library? They said that after download, rename. Oh, I have to download it. And install in restart Arduino IDE. Port A not supported. That's interesting. Okay, did you install yourself? Okay, get it. Select board. I guess you can do it later. So download it. Okay, let's just grab it from the newest one, not the release. Oh wait, I can just go here. Where's the Arduino Arduino libraries folder? Where is it on Linux? I don't know. Yeah, this piece. Well, where are they? They're just sketchbook folder and libraries. Okay, that's fine. It's called libraries. Yeah, libraries. Okay. So here we go. Git clone. Yes, that's exactly what I wanted. Here we go again then. Okay, it's in my library then. How do I rename it again? Rename the folder to, it's already that, and restore the IDE. Okay. Oh, I know what's going to happen. Because I didn't create actually a sketch, then it's going to, I guess, complain. Select board. I want Uno. That's Uno Mini. No, that's just Uno. Okay. But debugging is not supported. Whatever. Then give me 1 second. I need to figure out how to save my sketch as. Oh, it created an Arduino folder. I don't like it. Okay. On the chat you say Platform IO. Niestwierdzono says that Platform IO is much better experience than plain Arduino IDE. In honesty, like usually when I did this in the past, right, I just was using the command line Arduino stuff, because like a couple of versions ago they actually added command line compilation and uploading and so on. And so I was doing like Sublime and then and then this. Why not AVR dude? Why would I use AVR dude? So it's a bit more painful. I mean, Arduino IDE isn't bad at all. For prototyping, right? I don't use Arduino for anything else than prototyping, but for prototyping it's fine. Wait. Okay. Okay. Let's go to desktop again. Now let me close it and let's see what's going on. Oh, it created. We need to move it. Libraries into logo. Okay, now let's go again. Okay, then I need to go to restart Arduino, sketchbook library. This is this library, include library, and do we have it? Adapted neon pixel, why don't we have it? Maybe that's like, yeah, this Sketch Studio does look a lot like Visual Studio Code. Did they change something in the meantime? Second method, go to release, download. Yeah, I think I'm going to do this, you're right. So let's do that. That was, sorry, that was manage libraries. Or do I have to do click manage libraries, find library? Oh, I can do just that. That's funny. But I didn't have to install it. Okay, yeah, I should have read a little bit more. Oops. Yeah, okay, good. Where did it install itself in though? Doesn't matter too much, I think. Okay, cool. So now we have it, I guess, like sketch installed. Yeah, we have it. Okay, so now it works. Thank you for telling me that on the chat. And Yolex, thank you. Yeah, Vesim says, yep, that's Visual Studio Code. So yeah, I guess in the meantime they did change something. Let me turn this off. Okay, now let's get an example. Okay, if AVR, then blah, 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 pin 6. Let's just copy paste this. So, okay, so it's pin 6. It's pin 6, where do they say? Oh, here they say like, what is this? They create an object. This is actually like a global object? What? Or is it, what is this? Yeah, it's an object. That's a constructor. And these are parameters of a constructor. Okay. So that's funny. Do we have... Okay, what does it mean pin 6? Arduino pin out. It's just like pin 6 on an Uno? Because like Arduino has like so many... Like it has so many different pin numbers that is just ridiculous. Like for example, there are like these pin numbers, then there are these pin numbers, when there are like the ports and pin numbers. This is, so I'm guessing like they just mean this one. There's like really a PWM. This is a PWM port. So yeah, let's go just with this one, I think. Doesn't make sense, because why not? Okay, so that's pin number 6, I believe, is going to be here. Wrong kind of cable. I should really get into a habit of checking if both sides are what I need. Okay, I'm not going for color compatibility this time. I'm just going to go for... Okay, and now I need a rather long USB cable to be able to connect my computer to it. Okay, where's a USB cable? And do I have a USB cable like that? I think I should have, because I actually noticed I don't have cables like that, so I ordered a cable, which is like USB-A to, oh, this is USB 3, that's not good. This is USB 3 as well. This is absolutely the right one. This is USB B, but it's a tad short. What is this one? This one looks pretty heavy duty. Oh, this is a funny one. This is like USB A to A, which is kinda what you use for debugging. You can use it for or for connecting to computers. And from USB 3, you can actually connect to computers with USB. Not that almost like anything supports that, but technically you can. Yeah, it's going to be a pretty long cable, and I'm not sure. Like USB doesn't look like doesn't like long cables. So I'm not sure if this is going to work at all. But because I need to get it to my desk, and maybe no. I was thinking if I can steal the USB cable from the printer, but actually the printer is it? Yeah, it has data pins, but the printer actually is Wi-Fi now, so I guess that's not going to work. Let's put it here and get the cable to the other side of the room. It's not that far, it's just my desk across. So it might still work. If the camera bugs out, then please don't worry. Okay. So now before I connect, what I'm going to do is I'm going to run a console with dmask -h-w. Okay, and now is there anything sensitive here? No, there's nothing sensitive. Yeah, so okay, so I'm running this with dmask, and now I'm going to connect the Arduino, and let's see if it gets detected. Oh, wait. I kind of forgot a couple of more cables. I need to connect the ground and the power, otherwise nothing is going to blink at all. So, okay, we need a couple of more cables. Okay, so this is going to be ground. Do I have a... No, never mind. Where do I have a ground? Reset 5 volts ground. Here we go. And I need ground to be here. Yeah. And then I need... This isn't it. Oh, that's an old cable. Okay, this one. I need 5 volts. So 5 volts from this to this. Okay, that looks fun. Right? Let's double check now. Well, I guess ground is like the most important. 5 volts looks fine. Now I'm going to actually double check it before I run it. So where is the VDD? Is supposed to be on the other side of the triangle. Triangle is here, so this is VDD, and VDD is corrected here, and it goes here. VDD is triangle, VDD here. Yep, okay, so this looks good. This looks promising. And on the other side of VDD is supposed to be ground, and there is ground. That would be the triangle, and the triangle is connected to ground. Okay, I think I'm kinda happy with how it's connected. It's not going to get to like start blinking, obviously, when I connect this, but let's just see if it gets detected. I'm going to be happy if it gets detected. I think, oh, I'm actually not sure if I need to install any drivers on Linux. Okay, let's see what happened. Yeah, full speed device, vendor, something, Arduino. Okay, cool. So that gives me some hope. It gives me hope. Yes, thank you. I see on the chat you actually caught my mistake with like not powering the LEDs. Yeah, they do actually work better with power. I fully agree. Cool. So here, do you see my board? Board, Arduino Uno. Perfect, but do you see it? Okay, now you see it. Get board info. Let's see if it works. Okay, it gets it, which is good. Now can you compile the sketch and upload it? Verify and compile. Done compiling. Oh, you don't see it. I apologize for that. It's a done compiling. So let's just like push it, upload. Upload error. Okay. Permission denied. I guess I need to like chmod it. Is it enough for me to chmod it? Def tty. Why could I read like board information if I cannot? It's kind of weird. Or oh, dial out. Can I just join a group which is called dial out, and will that be enough? Let's check. I'm actually curious. Nimpixels too. You are right. Thank you. Ich bin Derby. I guess that's how you say your name. Or Udefrul. Okay. So how do I Ubuntu add user to group? I have absolutely no idea how I do that. Add user to group. Sudo add group. That sounds good. group add. No, wait, that's how I create a group. Add existing user. User mod -a-g example group. That's dial out. Why is it dial out? That's a funny group, but whatever, I'll take it. Okay. And now I believe I don't need to log out, but I need to close this. Now I need to Linux refresh user groups without logout. I always forget how do you do that without id-g. Oh, new group. Yeah, new group. This is how we do it. So where's my Arduino? Oh, that's my Arduino. No, that wasn't it. Here, new group. I know you can't see it, so dial out. Okay, id-g, and okay, I am now in the proper group, which means I can run Arduino IDE again. Here we go. Yeah, that sounds like dial out, sounds like modem, right? That's like kind of dial up-ish. There's usually dial up which was used, but dial out, whatever, well, Linux. So port, again, this one, why did it see now 2 other ports? I don't know. Okay, I still don't know how it got the port info, without actually like opening the port for reading whatever. Sketch, compile again, works, upload. Okay, now it works. And now let's switch to the desk. Hey, it blinks. Is it supposed to blink like that? I don't know. Not that is like... Let's turn off actually the lights for a second, because I'm actually kind of curious how... Wow, you cannot see anything. Why cannot you see anything? How do I fix this? Well, whatever. You can see it's blinking. I can see it's blinking. Let's turn the lights back on. Wait, how? That's pretty bright, actually. That is pretty bright. I know it's not visible, but it absolutely is bright. So now let's look at the code again, and let's see if it's supposed to be blinking like that, because one is like just full-time on, and the other one is blinking, right? So let's look at the code. The code says, should it be blinking? Num pixels, so for 2, and which one is blinking? By the way, the blinking is the second one? This is how it goes here. Yeah, the second one is blinking. So the first one is being constantly lit, and the other one is blinking. Pixels show. Well, the color matches. Hey, and that's not even full brightness. Can I make it a little bit bigger? How do I make it bigger? Edit. Font size? Where's the font size in this thing? Preferences, here we go. Font size, here we go. Okay. Then show, then delay. Oh, set pixel color for this one, and then show. And then it goes in a loop and it clears. Yeah, then it behaves okay. But that's fine. That's what it should be doing. It should be blinking. Okay. So what now? I guess we could like hook up an oscilloscope and look at the protocol, or better hook a logic analyzer, but oh, it's actually already 9, so I think I'm going to finish it for the day. And I know how it works now. I know that actually the pixels are addressable. So now I need to think a little bit about the PCB design, and then I'll make another live stream and I'll be designing the PCB for it, because it's going to be actually fun and weird. So yeah. Oops. So I think that's it for today, folks. Thank you very much for being here and suffering with me, and helping me, like, notice that I didn't connect the power actually, and stuff like that, or noticing the triangle. And yeah, and I'll continue with this later. So thank you everyone, and yeah, like if you're not on my Discord, I totally invite you. There's a like hardware and electronics channel there, where I throw like some photos from time to time of the progress on this project. So yeah, if you want to see them, you're invited. Thank you everyone, and yeah, and see you I don't know, in a few days probably. Bye bye.